Welcome. This is the presentation for our final project in Networks 2. This project was carried out by David Galvis, Kevin Vargas, Oscar Ruiz, and Paul Muwoz. Context. Our project focuses on a vehicle company with a presence in 3 strategic zones of Bogotá. The main objective of this initiative is to comprehensively develop the architecture, infrastructure, and network configuration of the company. This includes the selection of suitable equipment. Architecture. For the configuration of our network architecture, we use Draw.io, detailing the arrangement of necessary devices and their interconnections to ensure effective communication between the 3 locations. This analysis also addressed key security aspects reflected in the attached image. The main headquarters stand out by encompassing a greater number of devices compared to the 2 additional locations. These locations are interconnected through Layer 3 devices and connect to our DCP, WEB, and DNS servers. Additionally, we establish a connection to an AWS server. At the LAN level, the connection is made through switches, segmenting specific areas such as finance, administration, and support. Each location has its own access point to provide wireless connectivity to the network. This comprehensive approach ensures a robust and secure network structure tailored to the specific needs of each functional area at all locations. Infrastructure. For infrastructure planning, we use the key tools, Floor Planner to design our company's offices, and Google Maps to geolocate each of our locations in Bogotá with Floor Planner. Detailed 2D and 3D plans were created, assigning spaces to each area and strategically placing office devices and network connectivity. This process was replicated for each of the 3 locations, ensuring efficient organization of spaces and devices. Additionally, with Google Maps, we evaluated the location of each site, considering factors such as distance, latency, and security. These criteria were crucial in selecting sites for each location, ensuring an informed decision-making aligned with the operational and security requirements of the company. Equipment. For the selection of devices, an analysis was initially carried out regarding the fundamental components of the network, such as routers, servers, switches, and firewalls. The possibility of choosing multiple vendors was considered. However, after evaluating the advantages of having different vendors, the decision was made to opt for a single provider. This choice was based on seeking greater ease in network management and improving compatibility between various devices. Although we recognize that there are companies with more affordable costs, we did not consider the price factor as determinant in this instance. In this careful selection of devices for our corporate network, we have opted for a unified approach by choosing Cisco as our main provider. This decision is based on the pursuit of simplified management and greater compatibility between essential devices such as routers, switches, servers, and access points. In the provider selection phase, several options were explored. In this process, Cisco stood out as the most suitable provider, offering a wide range of options and having a consolidated reputation in the field of networks. The choice of specific models, such as the Cisco ISR4000 series for routers, Catalyst 9300-4P for switches, C220M5 for servers, Cisco Catalyst Series 9136 for access point, and HP devices for computers and personal devices, reflects the priority of efficiency, security, and scalability in our network. The implementation of wireless network segmentation through the access point demonstrates our commitment to security and personalized resource management. In summary, the comprehensive strategy aims to optimize performance, ensure security, and prepare our network for future business challenges. Configuration. In the configuration phase of our network, we address various aspects related to configuring devices at various layers of the OSI model. Initially, we configured the DNS servers, whose main function is to translate readable domain names into numerical IP addresses. This process is essential for computers to identify and communicate with each other on the network. Additionally, we implemented the configuration of our DHCP server, which dynamically assigns available IP addresses, preventing potential conflicts of duplicate addresses on the network. Furthermore, we dealt with the configuration of our web server, which manages and responds to client requests by sending web pages, HTML documents, and other content over the network. It is worth noting that we also have a server in the Oz Cloud, specifically on an EC2 instance. These instances are configurable virtual servers with various resources, according to the needs of our company, providing the necessary elasticity to adapt to demand. In the second layer of our network, we focused on configuring the switches. During this process, we assigned names to each switch, configured ports, and assigned VLANs in specific cases. Additionally, we used the VTP protocol to facilitate the administration and configuration of switches, thus optimizing the management of our network. In the third layer, we handled the configuration of routers, assigning names to each one, configuring ports, and establishing IP addresses and masks, among other components. These configurations were fundamental to ensuring successful communication between the three branches of our company. Finally, we addressed the topic of security by implementing a DMZ demilitarized zone for the connection between servers and our network. This measure contributes to strengthening the security of our infrastructure, providing an additional layer of protection. The sustainability of our project is based on various strategic decisions that span from planning to the implementation of infrastructure. During the planning stage, we use tools such as Floor Planner and Google Maps to optimize the design of offices and the location of branches, taking into account criteria such as spatial efficiency, distance, and security. This meticulous planning not only enhances operational efficiency, but also contributes to a more sustainable use of physical resources by reducing potential unnecessary travel. In the selection of devices, we adopt a unified approach with Cisco as the main supplier, prioritizing efficiency, security, and scalability. This decision not only simplifies network management, but also aims at optimizing energy consumption and the durability of equipment, crucial elements for long-term sustainability. Regarding network configuration, the implementation of virtual servers in the Oz Cloud strengthens our ability to adapt to demand, allowing efficient resource management and reducing the need for additional physical infrastructure investments. Conclusions. In conclusion, the vehicle company's project in Bogotá stands out for its comprehensive and strategic approach, from planning to the implementation of the network infrastructure. The careful choice of Cisco as the main supplier, attention to security across all network layers, and consideration of sustainability in branch locations and device configurations demonstrate a commitment to technological and operational excellence. The implementation of measures such as the DMZ and the use of technologies like virtual servers in the cloud underscore the focus on security and adaptability to demand. In summary, the project not only seeks to optimize performance and ensure security, but also aims to establish a sustainable foundation to address future business challenges. Finally, we have applied all the knowledge acquired throughout this semester, anticipating with expectations to achieve the goal of creating the network. We have strived to meet established standards and have incorporated new tools that have been crucial to conclude this project. in the most optimal way possible.